Hello everyone. In the last session, we have discussed about the classification of materials into conductor, semiconductor and insulator. In today's session, we will discuss more about semiconductor. So, first of all, the reason why semiconductors are widely used in electronic industry is that here we can control the flow of electrons. That is because conductors have no band gap, so electrons can freely move through them to generate electric current. Semiconductors, in contrast, have small band gap, and the flow of electrons and holes here can be controlled by adding impurities to the material. Let us learn more about this with the example of silicon. The electronic configuration shown here. It has 4 electrons in the valence shell. This particular point is very important because as per octet rule, stable state is achieved when 4 more electrons are gained. That is, if valence shell has 8 electrons. Okay, so this silicon atom gains stability by basically connecting or forming 4 covalent bonds with neighboring atoms, that is neighboring silicon atom. That is not all. Here again we have classification in semiconductor, which is called as intrinsic semiconductor and extrinsic semiconductor. When we say intrinsic semiconductor, it means pure semiconductor, okay, without any doping or impurity atom added to it. But when we say extrinsic or impure semiconductor, we basically dope or add an impurity atom, okay, into pure silicon crystal, if we consider the example of silicon. If we consider intrinsic semiconductor, we'll be having a silicon atom with 4 neighboring atoms, that is 4 other silicon atoms, which will have formed a covalent bond with this one. Okay, but if we consider extrinsic semiconductor, again we have some classifications, that is type N and type P. So, to understand what is type N and what is type P, we need to look at this particular figure which is shown here. As we can see, in the first case, if we consider N-type semiconductor, that means that we have basically doped a pentavalent impurity, which means that it consists of 5 valence electrons, 5 electrons in the valence shell. What happens because of this is an extra electron will be left in this particular system, okay, and hence it is called as N-type semiconductor. On the other hand, if any trivalent impurity is doped, in that case a particular vacancy will be created in the system, okay, that is called as P-type semiconductor. So that's all about today's session. Thank you.